Particles in Houdini are really something special, because they offer a wide variety of tools, they can be interfaced with most dynamic simulations, and under the hood they are just points that are being moved around, so they are extremely versatile. In fact, when you look at it, Houdini itself is maybe the most powerful particle system I've come to see. So let me give you a quick introduction of how particles in Houdini work with building this text wipe here. To start out, we're going to drop down a font to just generate a text here. Let's, for example, just use the number 5 here. What I want to make sure here is to uncheck whole faces, which in some instances, for example, the letter A could yield weird results, but we're going to fix that. So let's stick with the 5A maybe. And then let's drop down an ends sub. Attach that, set its close U to unroll with new points. And that's just going to give us the outline of the font. And now this hole here has been restored. Next, I want to make sure that the primitives, so the individual lines that form our font here, are ordered from left to right, so along the x-axis. In this case, that's already kind of happened. However, in some instances, some primitive numbers might be switched here. To take care of that, let's drop down a sort node, and under the primitive sort, set it to by x. And in this case, it just switched these primitive numbers here, so first, second, and third primitive here. Next, let's have a look at our font's points here, and let's distribute them more uniformly by dropping down a resample, wiring this in, and let's decrease the maximum segment length from 0.1 to 0.01, like so. Now we've got a dense line of points here. Next, I want to select a few points that move along those individual splines here. And I can do that by using a group by range node, that is, which I'll wire in here and highlight it. And I will set this up to select points. Let's call the group name emit. And I want to set the range type to start and length. So I can set a length of points that will be selected. In my case, let's use 10 points. With here, I can move the start point. So this group moves along the spline. And in here, all I want to do is, again, use a trusty expression, $ff for our current frame number, minus, let's say, 5 frames. So we'll offset the animation to start only at the 4th frame. Times, let's say, 5. And this dials in the speed of our animation. So again, what we're doing here is basically we're just taking our frame number, offsetting it a bit so it doesn't start on the very first frame, and then we're multiplying this frame number to speed up the animation. Let's toggle real time and hit play. And that's doing what I expected. Okay, so what we have now is an animated point group, which is called emit. Let's use that to emit particles by dropping down a popnet, attaching it directly to the group node here. And if we hit play now, this is what's going to happen. A few particles will spawn, these points that will fill the line. So let's set up this animation a bit. Let's get rid of the grid here and dive into our popnet here. And in here, you will find a dynamic net, which is denoted here by this font saying dynamics. And the logic behind these particle nets, those popnets, is really the same as behind the DOP nets, the dynamic operators that you're using for any other type of simulation. We need an object which stores our particles and our particle data. We need a source. We actually do not need this merge. This is just Houdini trying to be polite. And then all of this is wired into a pop solver, which is there to move our particles around. And then it goes into an output, and this data in the output is passed on to Houdini. So the first thing I want to set up is gravity. So let's hit tab and type gravity, and let's use this gravity force, which I'll wire in underneath the pop solver like so, and hit play again. And now I've got these particles falling down. Next, I want those particles to have an initial velocity, being maybe forced out along the z-axis here. And one way to set this up would be to write a v velocity attribute onto our emitter here. So just a vector called v that stores an initial velocity. And then in the popnet here, in the pop source, under attributes, it is automatically set up to use that velocity that's on the emitter. However, we do not have that set up, so let's use an initial velocity instead, setting this to maybe 20 along the z-axis, with a good bit of variance along all axes, maybe 5, 5, and 20. If we hit play again, we can see those particles are being spit out now. And also when we zoom out, they are falling down because gravity, like this. Okay, that's a bit too wild, I hear you say, and I'd agree, because what happens usually when you have those sparks that we are setting up like welding, they are slowed down by the air resistance. Let's add air resistance, which in this case is called drag. And we're going to use a pop drag particle operators, which we're going to wire in beneath our source here. Let's reset that, hit play again, and maybe let's increase our air resistance to, say, 2, reset this, and hit play again. And that's making a bit more sense. Then, these particles live long. However, sparks only have a short lifespan, just appearing and disappearing again. So let's reset this. Again, go to the source, and under birth, let's set the life expectancy to, say, 0.6 with a variance of 0.4. So now when we hit play, we can see those particles die down really quickly. Okay, let's set up this moving group as an emitter. So under source here, let's set our source group to mid. And now hit play again. And now we're seeing this, particles being spit out only where this emit group is. Apart from that, I'd like to add a ground plane so that those particles have something to collide with. And this goes into a merge. So merges in DOPs as well as SOPs are just there to connect data and not necessarily to build a hierarchy. Let's move this down a bit like so and hit play again. And now we can see those particles bounce a bit on the ground plane before they die. Okay, let's go up one level. And usually what I want to export here is not everything. So I do not care for this ground plane visualizer. And to select only our particles, let's just dive into the PopNet again. So the particles live in this pop object here. Up again. On the pop solver, instead of selecting any object there is, let's just select the pop object and hit play again, and now we are only accessing the particles themselves and piping them along to Houdini's geocontext. Okay, a few things. When I want to render them, Mantra by default renders these points as spheres. Redshift and Octane likewise can be set up to render those points as spheres. If worse comes to worse, you can use a copy to points to copy spheres onto these points and render geometry. And also when we middle mouse on this, we can see that we've got a velocity attribute now on those individual particles here. So that'll take care of those particles having proper motion blur. Sometimes if you want those streaks to appear longer, you could scale that attribute, for example using a point VOP or a point wrangle with a multiplication. Also regarding the initial velocity, I'm currently setting it up inside the PopNet. However, I could set it up on my geometry here on those points and create an attribute called V for velocity, a vector, which points into a given direction. By default, your PopNet would be set up so that it inherits this initial attribute. Very handy. Apart from that, when you dive into the PopNet, hit tab and start typing pop, you can see there's a multitude of operators that work on particles. And again, Houdini's documentation is very interesting when it comes to those, and also most of the time you can actually try those out by piping them usually in this stream here underneath your source. One last word about the logic behind this tree here. This tree does not purely denote data flow. It's more of an execution graph denoting which nodes get executed when. And this graph is executed bottom up, left to right. So in this case, we execute the output node, the gravity, then come to this merge. And then we execute the left input first, which is the ground plane, and then the right input, which is the pop solver. And in here, again, we'd first execute the pop object, and then the pop drag, and then the pop source. So what Houdini usually has is a merge setup in here by default, where you can also merge in, for example, this pop drag. So if we wire in the setup like this, it should result in the exact same behavior, which it does. So this syntax is sometimes a bit more clear than just wiring a giant string of operators and using merges instead. Also, you can see that particles are just points, so they execute really fast in Houdini and allow for really great experimentation and some really nice intricate setups. If you guys like what we're doing and want to support us, you might want to head over to our Patreon, and we'd like to thank all of our patrons, especially Refik Anadol, Chris Hebert, Important Looking Pirates, Encore VFX, Patrick Fillion, and Gearbox Studio Quebec. Thanks so much, guys.